Right, just a quick recap of the slope, also known as the gradient. Different ways of finding it. I guess the first time we saw it, we just simply said, rise over run is the slope. Then we formalised it a bit more. There's a line. We'll call it little l for line. And if we knew a couple of points on it, we came up with this wonderful formula, y2 minus y1 on x2 minus x1. Now, unlike the distance and midpoint formula, this one, it is important we get the y's and the x's the right way around. The y's have to be on top because, of course, that is the rise, and x have to be on bottom because that is the run. 5 minus 1 on 5 minus 2, we have a slope of 4/3. There is a third way of finding slope, often forgotten, and that's using the angle that it makes. So there's a line, capital L, and it's the angle always measured to the positive side. So in this case, we have an obtuse angle of 120 degrees. And the slope of that will be the tan of theta. Because if you think about it, again, it's that idea of we could create a right angled triangle if we wanted to. And if we did create a right angled triangle, the rise would be the opposite. The run would be the adjacent, so opposite over adjacent. We get the tan ratio. And the reason we go with the x side, or the positive side of the x's, is because when it's going down like this, we know it has a negative slope, so we need the obtuse angle, so tan will come up negative. So that's why we always go to the positive side of the x-axis. So our line, 120 degrees, would have a slope of negative √3. We know the slope of little l, 4/3, but we could work out that angle using trig as well. Let's do it. Call it alpha. Tan of alpha will be 4/3, not one of our exact ones, so we'll get an approximation, and it's around about 53 degrees, that particular one. Parallel lines. So one thing we know about parallel lines is they never meet, and so that means their slopes must be the same. No, I have not misspelt if that's what you're wondering. If and only if is what IFF means. And what it means, if you see if and only if, it means the theorem works both ways. So it's true to say that if two lines are parallel, they have the same slope, but it's also true to say that if two lines have the same slope, they are parallel. And you might think, doesn't everything work like that? Well, no, it doesn't. Let's see. Cats, generally, unless they've been involved in an accident, have 4 legs. So if it's a cat, I can say it has 4 legs. But it is not true to say if it has 4 legs, it is a cat. So not everything works both ways. In this case, it does. And that's what, as I say, if and only if means it works both ways. So slope 1 equals slope 2. And two lines are perpendicular, and again, it works both ways. If the slopes are the negative inverse of each other, or the way we more often think about it is we multiply the slopes together and we get -1. Okay, so A, B, C, and D are those points. Oh, we're missing one of our numbers, A. So we're going to find A such that AB is parallel to CD. Well, if AB is parallel to CD, I know that slope AB, which I can work out, that's 2, must be the same as slope CD, which is 2 on A minus 3. So, all right, let's equate them. So 2 must be 2 on A minus 3, A minus 3 must be 1, A is 4. But what if they were perpendicular? Well, now I know the two slopes must multiply together to get -1. So it gives me a different equation. And we can work out, in this case, A is -1. This is a classic problem, and you've probably seen it before. Very common sort of question where they give you 3 points of a quadrilateral. You've got to work out where the 4th point is. In this case, we're talking about a parallelogram. There's a long way of doing it, and there's a short way of doing it. So let's just plot the points. As much as people hate drawing diagrams, diagrams help, because we can visualize our problem. And the naming of the parallelogram is important. So it's A, B, C, D. That tells me D must be down here somewhere. I mean, if they had called it BACD, then D would be up there. So the naming, because we always name in cyclic order. So all right, I know D, well there's AB, there's BC, whoop, and D's down there. The quick way of working it out is using the fact that they're parallel. Because I know from going from B to D, I've gone across 3 and down 5. In other words, the slope, rise over run. Well, it must be the same for going to C to D. I must go across 3 and down 5. So therefore, XY is the point, there it is, 0, -10. And so that's the quick way to do it. What a lot of people do, and it works of course, but takes a lot more time, is they'll find the equation of the line CD, the equation of the line AD, find the point of intersection, and therefore that would be D. That takes a lot more work. Yeah.
Why don't you do it with midpoint?
Could you do it midpoint?
CA, the diagonals. Yeah.
Ah, yes. Again, you're using a feature of the parallelogram. So you could say, you know the diagonals bisect. The other thing we sometimes do is try and prove points are collinear. Co, of course, meaning together, linear line, so together on the same line. So I want to prove 3 points are collinear. Find the slope between 2 of them. Doesn't matter which 2. I've picked A and B. Then pick another 2. In this case, I've picked A and C. Now, if those slopes are the same, we know the lines are parallel. However, they contain a common point, that being A, so therefore they must be the same line. So that's probably the quickest way of showing lines are collinear. All right. 5B.